then does that. So that means that y can't be here. I'm going to divide both sides by y. If I divide, I get 1 over y dy dx is equal to x. Do we see what I've done there? I've divided this side by y, but I've kept it out of the dy dx part.
Wait, what
Okay, so remember what y is a function of x. So I can integrate both sides with respect to x.
Wait,
Bear with me.
Whoa.
We had this already, where the dx's will cancel out when we were doing integration before. So the dx's cancel out. So really we're just integrating 1 over y dy and x dx. So you derive with respect to y on this side, even though it's a function of x, and with respect to x on that side. No. Okay, so what's this one should be a piece of cake. X squared over 2 plus c. What's this one? ln y. We happy with that? 1 over y, yeah, ln y. Is it ln y plus c?
Yes.
Okay, this is where, yeah, so you could put in a plus c. Plus, you could put plus c1 here and plus c2 over here, and then when they come over, that'll be c1, c2 minus c1, which will just be another constant, which you still don't know. So you just kind of say there's going to be a constant in this expression. Yeah? Just keep it as c. But this is not our answer, because differential equations, what was our answers looking like yesterday? We had to have in terms of y equals, yeah. So we've ln y. How do I get rid of that ln y?
Divide by ln.
Yeah, you're thinking opposite. Yeah, it's not ln isn't multiplying by y. You're thinking the opposite operation. E, power of e, yeah. So if I raise both to the power of e, I end up with y and e x squared over 2 plus c. Well, we're not calling it c2. C. But we're undoing this absolute value. So technically it could be plus or minus with the absolute value there, yeah? Okay? There's an extra line that you're going to see in the answers here. That's okay for me, but there's an extra line you're going to see in the answers, and it is kind of constant terminology used, that they do this thing where we do plus or minus, watch EC times EX squared over 2. See what's happened there? Yeah. Adding, and we're undoing that adding. And they say, right, this is just some constant. Yes, some constant. So they do like a side note, plus or minus e to the c. They're just going to call a new thing. They could usually use the letter a capital A.
Do we have AC?
I would get used to it because you're going to see it. You're going to see it in the answer. So when you see, when it's an awkward constant like this, they just change it up and just write, it's still a constant. They can't use C again because you kind of already used it. They just use a different letter. You could use whatever letter you want, but they use capital A. Yeah, it's absolute value y, remember. Okay, let's do another one. Let's do a few, actually. Let's look. It's going to get more complicated, of course. I haven't looked at it yet. Oh, yeah, but the y is not in the right spot. You're right. It's just y squared, but the y isn't.
So it's just y.
What am I going to integrate with respect to?
Times y squared dy dx. Are we not doing the other side?
Y squared both sides, yeah. Multiply both sides by y squared. So you get y squared dy dx is equal to 1, yeah? And then I'm going to integrate this with respect to x. The dx is cancelled. Now I've done the separating. I've separated. You see that? The y is on left, x is on right. I can integrate this quite straight. Y cubed over 3 is equal to what's x plus c. Maybe get rid of the 3 first. 3x plus, what do I say? 3x plus 3c? C. Yeah, you just.
I don't get how that's allowed.
Yeah.
I don't get how you can.
It's still just. Oh, okay. Well, y is just a function. So you can integrate. It's like we did it earlier on, a bit like chain rule. You do the function within the function. We're dealing with the outside function here. You can think of it as like you're dealing with just the y-axis if you want.
Wait, what would it be? Would it be 3x plus 3c?
Yeah, it's a good point. Yeah, I suppose technically it's 3c, but it's some constant. We still don't know what it is. Later on, you'll find out what it is. Perhaps if you're given looking for a particular solution. Remember, this is a general solution. It's all c's, all constants. Could be anyone. It's a bunch of solutions. So this is then the cube root of 3x plus c.
But there's no a here.
There's no a here. There's no way of kind of separating that c from where it is. It's not a multiple like this where you can just multiply it by it. So just leave it as a c. There's no need. It's not complicated looking, for example. It's just c. It's not plus or minus e to the c.
But it just feels weird that, because it feels like you're doing different things to both sides. Like one side you're doing with respect to x, and one side.
No, you did both with respect to x, but the dx is cancelled out here, I suppose.
So you can just.
They're both function. Y is a function. Remember, y is a function of x.
Wait, if in the IB exams I wrote 3x plus 3c, would my marker be mad?
No, you wouldn't be mad. No.
No,
No, because you're just making it a bit more complicated for yourself. Because when you're not looking for the general solution, you got 3c instead of c. But you get this. You should get the same answer. 2y cosine 3x. Okay, so this is going to be the most complicated example. You can see here we're given some. What's this going to? How's this answer going to be different than this answer? We're going to find c. Yeah. They've given us some a particular solution that we're looking for, not a general solution.
Wait, but
particular solution.
Wait, is this the I method?
No.
No, because this is not a function of
Wait,
x.
why for both of them, they just say solve the differential equation, not.
Yeah. So this is called a general solution.
Yeah, so they should say that. 'Cause now
And this
I don't
is-
know that I have to find c.
Yeah, you won't be able to find c unless you're given some particular information. So we're looking for this is a particular solution. It's a general
Yeah, but
solution.
they still don't tell me that I have
I
to
know
find
that.
the
They're out to get you, tease. They're out to get you. All right, the same thing. 1 over e2y dy. I'm going to integrate it. Okay, we can put in the dx's and integrate cosine 3x dx. So what have I done? I've divided by e to the 2y, and then I've tried to done the two steps at once here. Integrate with respect to x, and then this dx cancels, so we just think about it as y. Let's come back to the left-hand side. Let's do the right-hand side because I think it's a little bit easier. What is that? Sine, so 1/3 sine 3x, or if you want over 3 plus c. This one then, what do I do here?
E to the negative 2y.
Yes, so I'll just write a little in-between step here. E to the negative 2y, what's the integral of that?
To the negative 2y over to the negative 2.
No, negative 2.
No, negative. No,
Yeah.
just e to the
No.
negative.
That's exactly what I said.
I just said e to the negative.
Oh, did you put it over?
Negative
Oh.
Okay, yeah, okay, I understand. Yep, okay, sweet, we're there.
What does your mom have?
Right, now we gotta, what do we do next? Yes.
Another question.
Yeah.
When you write that 1 over e2y dy dx times dx, do I have to write that dx or can I just straight write a dy?
Yeah, most people don't actually write that. When I've seen marked exams, they leave out that kind of dx and they just, you know that they cancel. So it's an assumed step that the dx's are gone and you've integrated both sides
No, but I like
with respect. But yes, you will end up almost certainly just ignoring this dx cancellation and just write dy, and that's fine. All right, we're at this stage. What do we do next? We still want in terms of y. So maybe multiply by -2. So e to the minus 2y is negative 2/3 sine 3x plus c, the classic that doesn't get multiplied.
Yeah. Negative 2y equals ln.
To the power, ln to the power of negative 2 over 3. Wait, no.
What?
Just ln e to
I think it's just ln, yeah.
It's negative.
Negative 2y is equal to ln, yeah.
Are we not finding c that? No.
Not yet. We can find, we'll find it.
We have to include the c times negative 1 over 2 now.
We're gonna use this at the end as soon as we have a general solution. Then we will
So we still find the general.
still find the general solution, then find the particular. It's probably the best way to go. You can sub in, of course, earlier, but it's a bit messy because we need y equals.
Have the negative
Because you're dealing with this where when you sub in 0, the whole function equals, not
C is 1.
half. Okay.
Wait, can't you?
Hmm? 2/3 sine 3x plus c, and then y is equal to negative a half ln. Am I right? Do correct me if I'm wrong. Okay, so we're at this stage. Now what do we do?
Now we sub in 0.
All right, sub in 0 for x, and what does it give us? 0. So if I sub in 0 for x, I will get 0 out. Okay, so what is c going to be then?
0. Is it?
I'm not sure. Minus 2, so minus 2, might as well write it down. Sine 0 plus c. So this bit is 0.
Is C meant to be inside the ln? No, right? It's just meant to be.
No, it is, yeah, it's because it's ln of the whole side, yeah.
C just does
You
not
can just put
exist.
e to the power of 0, which makes it 0. Oh, one.
C has to be 0.
What is ln's?
Leave it as negative 2y. It makes it easier.
Wait, doesn't it change the answer?
C is 0.
Oh,
Wait, what's
so,
ln
oh,
0?
so then you get negative. You can't have
ln 0 is 1.
Oh no, ln's 1.
You can't have ln 0.
No, I know.
Hmm?
C is 1.
You don't ln both sides.
C is 1?
C is 1,
No,
yeah.
Wait, what is ln 0? I'm so confused.
ln 1 is 0, so it's c is 1.
Yeah, you're getting there. Yeah. So I know this is 0. So we got, well, half ln, negative a half ln c is 0, yeah? Because this is 0, because sine 0 is 0.
So ln c is
ln c, so what value? Ln c is 0, so c has to be 1. So c is 1, so our general solution is when c is 1.